Okay, we have started the topic of spot speed studies, and travel time goes with the topic. Speed and travel time are interrelated. So basically, we have finished the topic of spot speed, and we have moved on to the part about travel time. Okay, so we have studied what do we mean by travel time studies, what are the requirements, why do we do them, what are the techniques to do the travel time studies, and then we looked at this table which shows a typical test car method of travel time data collection, and another table which shows something which is done locally. You can see there are less details, but the point is that we want to know the when the car passes one point to the next point to the next point, and if there was delay, what was the reason. Okay, now let's say and I mentioned it last time as well, that there are no new equations in this topic. In the travel time topic, there are no new equations. We are just using the old ones again. Okay, the ones which you already used in spot speed. So let's say we have an arterial. Okay, a hypothetical arterial which has a mean running time of 196 seconds. Okay, and it has a 3-mile section, and it has a standard deviation of 15 seconds. Okay, now we are discussing the topic of travel time. Okay, are they saying travel time? Are they saying this is the travel time? Yes. Yes or no? Come on.
Yes.
Yes, they are saying travel time. No, right? They are saying running time. Okay. The difference between travel time and running time is the delay. Without delay, it is called running time. With delay, it is called travel time. Okay? Anyone?
Run time without delay.
Running time without delay. Okay, and travel time is with delay. So whatever is given is for the running time. Okay. So they have given the mean and they have given the standard deviation. What they are asking for, first of all, they have made an assumption that the running time also follows normal distribution. Okay, like I mentioned earlier, that we are using the same topics and we are using the same equations. Okay, so normal distribution means the same thing here as well. Okay, clear? Everyone? Everyone is in the class, right? Or they are outside? Okay. They are asking for the 95%, the average speed and the 95% confidence interval of speeds. Using this data, they are asking that we should calculate the average speed and the 95% confidence interval of speed. Okay. If somebody gives you the time, how do you calculate the speed?
D over T. D over T.
D over T. Okay. So my T, if I am calculating the average, I'll take the mean of the time. If I want to calculate the average of the speed or the mean of the speed, I'll take the mean or the average of the time. Okay. And how much is the distance?
3 miles.
3 miles. Okay. So the average speed is no problem. You can calculate it. Okay. Everyone got what I did here?
Mike per hour.
Hmm?
Mike per hour.
Yeah. And how much is this?
55.
Any problem? So for average, I use the average. Okay. So that means following the same rule, if I want 95% of speed, I should calculate 95% of time, right? Using the same principle, if I used mean of time to calculate mean of speed, I should calculate 95% of time, 95% interval of time to calculate 95% interval of speed. Clear or not? Okay.
Okay.
Now,
I didn't get.
because you were writing.
So I will-
Yes, because both of you were writing. Yes, I know. Okay. And a lesson for everybody. I know you guys do it, and there's no ill intention here. You have to do it, obviously. You should do it. But like you have to decide when you would write and you would listen. You cannot do both. Okay? You should know your limit. You cannot do both. So if there's something you need to listen, don't write at that time. You will miss it. Okay. So I'm saying that when we needed average speed, I used average time, right? If I want 95% confidence of interval of speed, I will use 95% confidence interval of time. So here I need this value, right? I need this value. Will the distance change? No, it's the same highway. Distance cannot change. Okay. So I need to find out what value should I use for the 95% confidence interval of speed. Clear or not? Okay. 95% confidence interval of anything. Okay, anything. According to central limit theorem, which we have studied in the spot speed topic, is mean plus minus 1.96 E. Okay, this is the equation, just trust me. You should remember. Okay, the same equation which we had for the spot speed. Okay, in this equation, E is S upon square root of N. Okay, clear? Now, do we have the things to calculate E? No. What is missing? N is missing. Okay. Now, something which is from statistics. Okay, so even if you don't understand this, remember it. Okay. There was a whole course on statistics. So if you don't understand after that course, just remember what I'm saying. Okay. So they are saying this is the true mean running time. Okay. Whenever we use the word true, it refers to, it doesn't refer to a sample. It refers to the whole population of drivers. Okay. So somehow they found the mean for all drivers, not a sample of drivers. Okay. The spot speed data which we analyzed had a sample, right? 300 something values. This value is not for a sample. It's for the whole population of drivers. How do I know that? Because they are using the word true with the parameter. Okay. So whenever a statistic is given and the word true is written, that means it refers to the entire population. Got it? Clear? Okay. For the entire population, when they say standard deviation, it is basically the standard error itself. Okay? Clear? Because usually you will have a sample. From sample you will calculate E, right? And this S is for the sample. That's why we need E. Okay? That's why we need E. But If this is not for a sample, then this becomes E. Okay? Clear? Huh? Who is that? Get out. You? Get out. Okay. This equation converts standard deviation of a sample into E. Okay? If I can get the standard deviation of the entire population, that is E. No conversion. This is like a conversion equation. Okay? Like what you were doing here. This was in seconds, you converted to hours, right? But if I give it in hours, you will not do the conversion, right? Same thing here. Clear? 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 You are convinced? Huh? Good?
So
Good or
we use
convinced?
A to convert from sample to population.
Okay? Clear? I'm trying to make it very easy, but it's not so easy. Life is not easy. But you guys can enjoy until you get in the field, right? Okay, so the fact of the matter is E is this. Okay? And how do I know that this is for the population, not for a sample?
Through me.
Because the word true is used here. Clear? Okay? So this is my E. I already know the E. I already know the mean. Okay? Give me the confidence interval. This is the confidence interval of time. Okay? Use it to calculate the confidence interval of speed. Yes. Sleeping or awake? What is this?
This is the time, this is the speed.
Why are you making faces? Did you calculate it? Don't make faces until you.
We need
It's
the
correct.
speed also, or just
Huh?
we need the speed.
We need this videos. I know. Sabr. Sabr Jamil. Okay. Any problem here? This is clear? Okay. Now I'll go back to this equation. I replace 196 once with this one, then with this one. Okay. I'll get the 95% confidence level of speed. How much?
Support,
No support for me.
47.9.
No, I write in the same
Yes,
format.
sir.
64.8, 47. Okay. Any problem? Any problem? All clear? Okay. Now this speed is the mean speed, right? The first one, 55.1, is the mean speed. We have studied two types of mean speeds: space mean speed, time mean speed. Which one is this, and which one is the mean of spot speed? Is this time mean speed or space mean speed? This is space mean speed. How do I know that? Huh? No. Distance. It has a distance, a long distance. Okay. So if you are getting speeds from travel time, and I told you earlier travel time cannot be for short distance. So that becomes the space mean speed. Okay, and the spot speed is the other one. Okay, that will be the time mean speed, because spot means it's a point. Okay, so there we restrict the distance as well. Even if you are doing distance upon time, the distance cannot be 3 miles. It will be a very short distance. Okay, so the mean of a spot speed is time mean speed. Okay, and the mean which you get from travel time studies is the space mean speed. Clear? Okay. Okay. Travel time data, number of observations. Okay, we call it the n value, small n. Okay, so for every travel time, I have the values on the y-axis. When we are doing the spot speed, there was a table, right? In the table, there was middle speed. There were groups, right? 32, 34, 34 to 36. Okay, and there was middle of each group, and for each group there was n number of values. Okay, so that thing is now plotted here for travel time. So this is like the middle of the group, and this is the number of values in that group. Okay, you can do the same thing with spot speed as well. Clear? Okay, it's the same data which we had earlier for the spot speed table. Okay, the middle values and the number of observations. Clear? Okay, so 150 group had one value, 160 group had one value, 170 0. Okay, 180 1, 190 2, and so on. Clear? Okay, now they are saying that this is the travel time data, and we have to calculate the same, the average speed and the 95% confidence interval of speed. Okay, but here the mean standard deviation is not given, the data is given, and we will calculate it. Okay, now these equations which you see are the same which we have used for spot speed. Okay, so only the data representation has changed. There it was a table, here it's a graph, a frequency bar diagram. Okay, but the equations are same and we calculate in the same manner. Yes?
Can we consider this normally distributed?
Huh?
Is this normally distributed? Because it has 2 bits. So how can we use the standard deviation in the mean?
Mean and standard deviation has nothing to do with normal distribution. The central limit theorem 95% interval is this comes from normal distribution. Okay. Yes, it doesn't look like normal distribution, but there's a check for it. Until we do the check, we are assuming that it's normal. Okay, because even the spot speed was not completely normal. There were some points going up and down. So maybe if you joined all the points, you will not get a smooth curve. Okay, so that's why we had the test. Anybody remembers the name of the test which we do for normal distribution? Chi-square. Okay, so yes, it does not look like a normal distribution, but to be that sure about it, we have to do the chi-square test. Okay, we are not doing it now, we are just focusing on these calculations right now, but you know how to do the chi-square test. Okay, so we start with the mean. Okay, so you take the n for every bar, take the n from the y-axis and s from the x-axis. Okay, and this is the equation for the mean. How much is total n? 20. How do I know it's 20?
It's written down.
It's written down. Okay, can I check if it is 20 or not?
Count
I count what? Huh?
Frequency in each group and
The frequency in each group. Okay, don't count the number of bars. Okay, don't count the number of bars. If you see the number of bars, how many bars we have? Do we have 20 bars? If you count the number of bars, they are not 20. Okay, I'm counting the number of each bar from the y-axis. So 1 plus 1 plus 1 plus something, something, something. Clear? Okay. So n is 20, give me the mean.
21815.
Okay. Then the standard deviation. Who found out how to do this calculation of mean and standard deviation from these calculators?
Can.
Huh?
Can.
You can do, right? Who else knows how to do it? Now, I told you can do. Who else knows how to do it? Huh? Who is we? The people who are thinking, what the hell is he talking about? Who is we? You are no longer IC president, okay? Those who say we, say me, I. Right, Allah? Yes. Okay, give me the answer then. 38.29. I gave you a check about mean and standard deviation. You can check if your standard deviation is correct or not. What was that check? Anybody remembers? See, because of this person, you'll get a question in the exam like this. I'll ask you to do 85 percentile, 15 percentile. I'll put this reference so you can remember him in your prayers. Yes. I'm not talking about that check. No. I'm not so intelligent. I'm talking about something very easy. What did I tell you about if you have the mean and you calculate standard deviation? Yeah, standard deviation should be less than the mean. See? Life is easy.
Other check.
Other check, no other check. Okay, clear? It should be less than the mean. Which it is? Okay. So we can proceed. Okay. We will do the same thing. We will calculate the 95% confidence interval of time now. Okay, I have the mean, I have the standard deviation, I can calculate the 95% confidence interval of time. So this is the equation for 95% confidence interval. Okay. First of all, the E value. Do I need it? In the last example, I did not calculate the E value. Should I calculate E in this example? Why? Because there are the number of samples. Okay. So give me the E value. Okay, now you can calculate 95% confidence interval of time, which is how much? How much? And 201.6. Okay, this is time. To calculate the speed, I need the distance, right? Okay, distance is written here. Distance is written here, and this is the only way you will know the distance. Okay. So 95% confidence interval of speed. Sorry, we start with average speed. How much is average? Average speed. Same, 3 months. $49.4. Okay, now the 95% confidence interval of speed. Anyone having any problems? We are using this distance and we are using these times. This one is used, this one is used for the average, and these two values will be used for 95% confidence interval. Clear? Any problems? Any questions? Okay, a small clarification. You cannot calculate the 95% confidence interval of speed directly using the average speed and the standard deviation of travel time. You cannot do it. Okay? Clear? This is for the confidence interval, right? This is the equation for confidence interval. Okay? In this equation, you have the mean and you have the E. Okay? In one of the previous years and semesters, somebody did what? They calculate the E for time, and then they put the mean of speed and try to calculate the confidence interval of speed directly. This will not work. Okay? Because the time has a different scale. The time is in hundreds, you can see here. The speed is not even crossing 60. So you cannot take the standard deviation of something which is in hundreds and try to calculate something which is so small. Okay? So you will get negative answers or speeds which are more than 100, 200. Okay? So we don't do this. Okay? In every equation you are using the same thing. Mean of speed, then mean of standard deviation of speed as well. If you are using mean of time, then standard deviation of time. Clear? Okay. Any questions, any problems? Somebody has the values?
Answer 53.54. 45.9.
Okay. Clear? Okay. Now let's say this is a 3-mile arterial, and the previous question was also 3-mile arterial, right? In the previous question, they gave me mean of running time, which was 196. Okay. In this question, you calculate the mean of travel time, which is 218.5. Let's say these values are for the same highway. The running time and the travel time are for the same highway. If you know these two values, you can calculate something, a third value, which is what? Delay. Okay. So delay is the difference between travel time and running time. Okay. So 218.5 minus 196. Okay. The two values were given separately, but I know the difference between them is delay. So I calculate the delay. Clear? Okay. Any questions? Okay. Now this is another method of calculating the delay by using the chance of, because delay is something which is random. It's not fixed that every car in the stream will have the same amount of delay. Okay. So in this example, the possibility of delay is calculated, chance of delay is calculated, okay, on the basis of number of stops on the signals. Okay. In the same chapter later on, we will do the calculation for delay on a signal. Okay. So we will be calculating these percentages as well. Okay. So you can calculate how many vehicles are stopping at the signal. Okay. And then from the total, you can calculate how many are stopping on a series of signals. Okay, what do they call it? What probability? If you stopped at the first signal, the possibility of stopping at the second signal, what do they call it? Okay, anyways. So the possibility of not stopping at any signal So this is the combined possibility, combined probability. You did not stop at the first signal, you did not stop at the second signal. This is for one stop. You stopped at the first signal, you did not stop at the second one. Or you did not stop at the first one, but you stopped at the second one. Okay, so this is the combined possibility of passing through the both signals with one stop. And this is the combined possibility of passing through both signals, stopping and stopping. Okay, clear? So this is not the possibility for one signal only. This is for both of them. Okay, so there is 56.9% chances if you are calculating the percentage of chance. So 56.9% of the vehicles, when they pass, they don't stop at any signal. Both signals are green for them. 30% of the vehicles, they stop at least one of them, any one. And 13% remaining, this plus this, minus 100. Okay, so remaining stop at both signals. Okay, clear? Okay, this happens when you are doing signal coordination. It can only happen for one direction. So we are not talking about the whole highway. We are talking about only one side. Clear? Okay, everybody? Yeah.
This is assuming there is nothing between the two intersections.
Yes, yes. No other stoppage. Okay. Face doesn't say this. Anyways, good for me. Keep it up. Okay. So if you want to calculate the delay, we will use these possibilities. Now we don't have a fixed value. We have the possibility with each value. So if you don't stop at any of the signals, your delay is 0, obviously, because there is nothing in between them. Okay, so the only delay causing thing is the signal. So if you don't stop at the signal, your delay is 0. If you stop at one of the signals, your delay is 40 seconds. If you stop at both of the signals, the delay is 80 seconds. Again, average. It's an average. Okay, so we have the average delay and we have the possibility. If I want to calculate the average for all vehicles, I'll take the value, multiply with the possibility. Okay, if I take this value and multiply with the possibility, it will become what? 0. So 0. Okay, if I take this value, possibility is 30%. Okay, and if I take the last value, the possibility is 13.1%. Okay, anyone has any problem? Clear? Okay, so either you measure the running time and travel time separately, so you can know the delay exactly. Okay, or if you have the percentages, the chances, the probabilities of having the delay, you can do something like this. Okay. Okay. Again, using the same equation which we have seen for the spot speed to calculate the number of samples. Okay, you are required to use this equation in your term projects as well. So we have a series of travel time for an radius section. We have to find out how many number of runs are required. You will find this phrase or find this term used for the number of samples of travel time, runs. Okay, so don't run. This means a sample. Okay, for travel time, this means a sample. Okay, so when they say find out the number of runs, they are saying find out the number of samples. Okay, so they want 95% confidence interval. So this equation is for 95% confidence interval. Okay, if I take another confidence interval, what will change in this equation? Anyone? The number will change, right? Everything else will remain the same. Okay, so confidence interval only changes this number. Okay, and they want to be precise within 2, 5 and 10 minutes. Okay, and they are changing the standard deviation 5, 10 and 15. Okay, so they are changing the standard deviation. And what is this? Which value? The E value. Okay. Okay, so standard deviation can be 5, 10, and what, 15, and the E can be 2, and you can see every time they write E they do plus minus, okay, because it is related to confidence interval, that's why. So it can be plus or minus. Okay, you have the equation, you have the values. Tell me. 24,
96.
down or right? Right. 96, 216,
Down.
down.
3.8.
15.36.
34.46.
Huh? 0.96.
8.64. 8.64.
Okay, first of all, look at the second row. How many samples I will take here? 4. How many samples I take here? 16. Why not 15? 15 is closer, right? So why 16? It will be less than the required. Okay, we will not maintain E then in that case. Okay, so you cannot round down. Okay, another thing you can see, when E increases, the number of values required are less. E is your precision level. Okay, so if you don't want to be precise, you can have less values. Okay, people who pass the course in first attempt, your precision is very low. You should repeat the course 2-3 times. Then you will get your precise grade. Okay? Okay. The standard deviation, when it increases, the number of samples are increasing. Okay? Because standard deviation shows a variation in the data. So standard deviation is increasing, that means the data is becoming more varied. To cover this variation, I need more samples. Got it? Okay, if there is more variation in the data and I want to cover it, then I need more samples. Got it? Clear or not? Okay. These are the results of 5 travel time runs. Okay, and runs means what? Samples. Okay. So these values are already an average of 5. Okay. So they started from this point and they ended at this point. These are intermediate points. At every point they took the observation for distance, cumulative, and travel time, cumulative. Okay. At every intermediate point. Then they also found the observation for delay. Okay, but the delay is not cumulative, you can see. Okay, so delay is for this section only. Okay, so this 2.25 is cumulative, meaning from 1 to 3. Same thing with the travel time. But the delay, this 30 seconds, it's not from 1 to 3. It's between these 2 points, 2 and 3. Clear? Same thing with the number of stops. Okay? Okay. The first thing they are asking is they want the travel time, they want the average speed and average running time for each section. For each section, they want the average speed and the average travel speed and average running speed. Okay. How many sections we have? There are 7 points. So how many sections? 6. Section 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Okay, to calculate the travel speed, I need the travel time. To calculate the running speed, I need the running time. Okay, and the difference between them is the delay. Clear? Okay. First of all, I will calculate travel time. Between point 1 and 2, the travel time is 2.05, right? Huh? Between 1 and 2? Not 2.05, sorry. 2 minutes 50 seconds. Oh, sorry, 2 minutes 5 seconds. 2 minutes 5 seconds, right? Is 2 minutes 5 seconds equal to 2.05? Yes? No? No? Okay. It will be equal in a universe where 1 minute is equal to 100 seconds. And unfortunately, we are not in that universe. Okay? So, it's something else. If you want, you can make your life easy and you can put all of them, convert all of them into full seconds. Okay? So, convert 2 into seconds and then plus 5, and 4 into seconds and plus. This is also fine. Okay? Or convert all of them into minutes, no problem. Okay? Clear or not? So, now between 2 and 3, I have to take the difference, right? Because this is cumulative. I have to take the difference. Okay? So 4 minutes 50 seconds minus 2 minutes 5 seconds. Okay? So 4 minus 2, it will be 2 minutes 50 seconds. Then 5 seconds minus 2 minutes 45 seconds. It was 2 minutes. Okay, so 4 minus 2, you have 2 minutes. And 50 minus 5, you have 45. Clear? Okay? Okay, next one, how much time? 3 minutes 20 seconds?
2 minutes and 40 seconds.
2 minutes 40 seconds? This is 730 minus 450. 730, 450. 7 minus 4, 3. Okay, but 30 minus 50, it will give minus 20, right? So from where you will do minus 20? From 3, right? So this 3 will become 2. And minus 20 means 60 minus 20 is 40 seconds. Clear or not? Any problem?
Can be done calculator also.
Yes. Can be, yes. Like you do degrees and seconds for the angle, same thing. Same thing. Okay, next. How much? 910 minus 730. 1 something, right? 1? 40? Okay, next. 10:27 minus 9:10. 240. Which one did I do? I'm going between 3 and 4, right? I'm doing this one, right? So 9:10 minus 7:30. It's not 140. You will do 9 minus 7. It will be 230. Oh, sorry. 9 minus 7 will be 2. 10 minus 30. No, 140.
No, but you didn't do between 7:30 and 4:50.
I didn't do which one? I did this one, right? I didn't do this one. I did this. 205, same. Then I did this 245. Then I did this. Which one? I didn't write it. Okay. Okay. The next one is 140. Okay. Okay. The next one 117. 127. Okay. Now I need the running time. The difference between running time and travel time is delay. Okay. You have the travel time now. You have the delay now. Okay. Shouldn't be a problem. So 205 minus 10 seconds, 195, right? How much?
10 seconds delay.
Yeah,
205 minus 10,
55. Okay. Okay, 45 minus 30. 240 minus 25. 250. Huh? Okay, 140 minus 42. 0.5. See? It's catching up. Yes. So how much? 117 minus 47. Okay, and 127 minus 14. Any problems? Clear? Huh? Okay. Okay, now I need the length. The length is also cumulative. The first one is 1 mile. For second one, I will take the difference. Okay. Okay. Any problem? It's all clear? The problem is clear, your head is clear. Which one is it? Question is clear, the head is clear. Question is clear. Your head is still spinning, right? Okay. You have the distance, you have the time, distance upon time. Okay. So for example, if you are calculating travel speed, you will take travel time, okay, distance upon travel time, okay, but remember this is minutes, this is seconds, okay, so it will be 1 divided by 2 upon 60 plus 5 upon 60 into 60, okay. Don't convert all of it into, or if you already convert it into seconds, then it becomes easy, right? Clear or not? Okay, 2 divided by 60 because 2 is minutes, and 5 divided by 60 into 60 because 5 is seconds. You will get the answer in how much? Like you get the answer in what units? Miles per hour. Yes. 5 seconds, right? 2 minutes, 0.5. See, when I'm explaining 255 is not equal to 2.55, you guys are, what is he talking about? You all know this. and then you guys will do this, right? Okay, clear? Okay.
For the speed you will use travel time.
For
The speed you will use travel time.
For travel speed, you will use travel time. For running speed, you will use running time. Okay. The values are calculated. Okay. These values are calculated in the same manner that you showed you. Okay. Clear or not? Any problem? Any question? Why are you angry? Okay. This is the graph between the two speeds, the running speed and the travel speed. Okay, if you calculated running speed and the travel speed for the same sections, which one should be higher or can be higher? Not could, should be. Which one can be higher? Running speed can be higher because running time is equal or less than the travel time. Okay, if no delay, they are equal. If there's a delay, then travel time will be higher, then travel speed will be lower. Clear? So again, like a check. And this one is the travel time and delay graph. Okay, looking at this graph, you can tell me which section has a bigger problem. It was a traffic engineering section, right? Yes.
5 to 6.
5 to 6. Which one is this? Why 5 to 6? Why not 2 to 3? It has the highest travel time. Huh? More delay. 2 to 3 has the highest travel time. If you look at the length, it has the highest length as well. Obviously, it makes sense. It will have more travel time. Okay. But here, the travel time is less than all the other sections. But compared to them, the delay is also higher. So least travel time and highest delay. Not a good combination. So if I remove this one, the travel time will be only this much. Okay, this much, right? This much. Okay. So if you want to find out the problematic section, we don't look at the travel time only. You have to consider how much is the delay, because travel time could be because or should be because of the length of the road and what else? What else? Speed. Not the speed, like obviously if there's traffic jam or something, some problem, we will see the delay as well. But I'm talking about the design speed. So your travel time can be longer because the road is designed for a lower speed and it has long length. Okay, so it will make the travel time longer, but it does not show a problem. Travel time is longer because the road is such. Okay, but the travel time is longer because of the proportion of the delay, that's a problem. Okay. Now, these are the travel speeds and the running speeds. Okay, and now they are saying that you have to find out how many test vehicles should be applied on this highway to take another sample. I told you, and you have done it for your projects as well, that we take a small sample. You did how many samples? In the first submission, how many? 10, right? It's a small sample to do what? So that you can do the calculations later on for standard deviation for number of samples. Same thing is done here. How many samples were these? How many samples? It's a summary of 5 runs. Okay, 5 is obviously not complete samples. So they took 5 runs so that they can later on calculate number of samples for the actual survey, for the actual study. Okay, so now to calculate the number of samples, we are using the same equation, right? The equation which we had for the spot speed case, which is this one. Okay. So what is this 3? E. Okay. Given with plus minus. What do I need to calculate before I move forward? Standard deviation. Okay. If you go to spot speed topic, you will see 2 equations for standard deviation. One which we have been using up till now. We used it for travel time in the last example. We used it for spot speed data as well. Okay. That equation, this one. This one is when you have frequency distribution, like what we had here, what we had in the previous case. Do we have any frequency distribution here? There is no frequency distribution, right? Okay, these are just plain, how many? 6 values. Okay, so I cannot use the same equation. I'll use a simpler equation of standard deviation. Again, it's part of your calculator and Excel as well, which is this one. Okay, every value minus a mean upon number of samples minus 1. The square and the square root. Okay, clear? How many samples I have? No, I'm doing it for these values, right? How many values I have? Those 5, they already took the average, right? It's done. Yes, how many? We have 6, right? We are doing it for 6 values. Okay, so my n is 6. And I need the mean as well. So how much is the mean for each case? I need the mean for travel and I need the mean for running speed for both of them. So what is the mean? Again, simple mean. There is no need to do the frequency distribution mean, the previous one. So what is the mean of travel speed, travel speed? 24.50, 53. Very good. When we were in high schools, this is the only thing which we knew to, find out mistakes in others. 0.53 cannot be, right? 0.53. No problem, no problem. Yes, and mean of running speed is 32.65, not 65. Okay, what is the standard deviation for each case now? Again, you can, there in the calculator, you can just do it.
We can
Or use what?
this equation.
I think so. I think so. I don't know what it is. But if it is big and scary, you can use it. Yes. Sure. You can use Excel as well. People were asking me in the exam, can I use Excel? Now they are not even paying attention. That is like, yes. How much is the standard deviation? Yes, how much? What?
He's saying that the mean you got is wrong.
The mean you gave me is wrong.
No, I said 24.15.
24.15. Oh my God. We destroyed the whole world. Okay. Now saved. How much is the standard deviation? Okay, and this one? Okay, then number of samples. E will remain the same, equation will remain the same, only the standard deviation will change. 20, 20.3. Sure. No? I cannot. This is what he told me when he took the course first time. Yes, how much? $20.3. Okay, I don't care. Okay, no problem. Okay, the other one. 2.2. Okay. So 20.3 means 21 samples. 2.2 means 3 samples. Okay. Now if you look at the question, they are saying that if you remember, I told you we have the test car technique in which you hire the cars, and you allow them to do the observations for you. Okay. So they are asking how many cars should be hired. How many cars should be hired? And they are limiting each car to 5 runs, 5 samples. Okay. So for example, now here you need 21 samples, right? You need 21 samples. Okay. To collect 21 samples, how many cars you will hire? How many? Each car will do 5 maximum. So how many cars you need to do 21? 5 cars, right? 4 cars will do 5, 5, 5, 5, 20, and then you have the 5th car will do the 21st. Okay, and in this case you need only 1 car. Okay, clear? Okay, then we have the concept of travel time contour map. So up till now we have been talking about taking travel time along a highway, along a route. Now we are going on to another a higher scale, which is taking travel time for an entire area from a reference point. So you start from a reference point and you go in different directions. Okay, and take observations. So if I go in this direction, and obviously not one observation, you take multiple. Okay, so if I go in this direction, in 25 minutes I will reach here, in 50 minutes I will reach here, in 1 hour I will reach here. Okay, and same thing with the other direction. Okay, so for example, this is your reference point. So from this reference point I can go here, here, here and here, right? So when I go here, in 15 minutes I reach here. If I go in this direction, in 15 minutes I reach this point, and same thing in all the other directions. Okay, so this line shows what? A contour of 15 minutes, not elevation. That's why we call it the travel time contour. Okay, not the elevation contour. Okay, so you take a reference point. From that reference point, you measure travel time in all directions possible, all possible directions. Okay, and then you select a travel time interval for which you will draw the line, the contour line. Here they have taken 2 intervals, 15 minutes and 30 minutes. Okay, so you see 2 contour lines here, 15 and 30. Okay, but to plot this line, you have to go in all directions from the reference point, right? So it's no longer a problem of getting travel time of a route or a highway, but getting travel time for the entire area. Got it? Understood? The concept is understood. How do we plot the travel time contour map? Okay. Now why do we do it? We do it to find out the area of interest for our reference point. Now this reference point must be some sort of facility which people can use. It could be an airport, it could be a hospital, it could be a bank. Okay, so obviously if you have different options for a particular facility, your decision in most of the cases is based upon travel time. Okay, so if you know how much area is covered for a particular travel time interval, you know the population of interest. Okay, that I can expect people from this much area to come to my facility. Okay, so for example, if it's a mall, okay, and I'm deciding what type of things should I keep in my mall. Okay, so this travel time can help me. That most of the times people who are within this range would like to come to this mall because it's near. Okay, people who are away from this range, their chances of coming is very low or lower, right? So then I will look, okay, who are these people? Low income, high income, okay, what type of things they like, Balinese, non-Balinese, whatever, okay, and then I will design my facility, design my parking lot. I will look at the population, okay, how much population in this area I have, okay, maybe the population is very low, so I don't need to build a 20-story mall now, nobody will come, okay, I don't have that much people living nearby, got it? Okay, there are a couple of malls who have actually failed because of this reason, they were very far, people don't go there. Yes.
They did this thing for the university here.
What?
They did this.
Yeah, they were trying to stop you guys, but you don't listen, you don't see. Now I'm teaching you, you should have seen this earlier. You get the point? Okay. This is also called as a catchment area, the same thing which you use in structures and waters. Okay. It will tells you from which area you can expect your load, right? Okay. Another method of showing a travel time data is using a time space diagram or a time distance diagram. Okay, this is again along a route. Okay, and these are the intermediate points. Okay, so I showed you the table, right? This is the plot of this table. I am at this point on this time. I am at this point on this time. Okay, so you plot this line. Clear? Okay. Now this line you can see sometimes it goes vertical. This is distance, this is time. So when the line goes vertical, the car is stopped. Okay, so you can get the stopping time from here. Okay, you look at the last value, you get the total distance. You look at the last value on time, you get the total time. Okay, and we know if you do distance upon time, you get what? Speed. Okay, so you can do distance upon time, you can get the average speed as well. You can plot it as well. Okay, but this is usually done for longer routes, not one highway, like from point A to point B, which can include many highways and streets and so on. Okay, next thing we move on to is intersection delay studies. Okay, I mentioned earlier that we do it manually. Okay, and we know intersection can be of different types, right? We have signals, we have roundabouts, we have stop signs. We will focus here on roundabouts and signals. Okay, stop sign we don't care. Nobody stops at them, right? That's why. Their delay at the intersection can be of different types. Later on, we will study different types of delay at the intersection. Right now, we are the delay which we are going to calculate is called control delay. But there are other types as well. One of them you already saw for the highways, which was a delay when the car is what? Stopped. Okay, so there is one which is called stop delay, and there is another one which is called as control delay. Okay, stop delay only has a time when the car is stopped. Control delay has three things. Control delay has three things. It has deceleration before joining the queue. It has the time which you spend in the queue, and it has the acceleration after you leave the queue. Okay, so control delay actually starts even before you join the queue. Okay, so you see the signal is red, there are 4 cars in front of which are stopped. Okay, so you start decelerating. This is the start of your control delay. Signal becomes green, you start moving forward and you cross the signal, now you start to accelerate, right? The acceleration time is also part of control delay. Got it? Okay, now let's say you are the 5th car in the row. You are the 5th car in the row. So you will reach the signal after 4 cars, right? When the signal will become green, you will start moving. This time is part of your queue time. This time is part of your time in the queue. Okay. Okay, next time.